So we've seen 5 predictions, logical predictions that are made by nebular hypothesis. We looked for those observable predictions, and in all 5 cases we found them. And so we've built up an argument, a case for the nebular hypothesis in the same way that a lawyer builds up a case in a court using, remember, what we called abductive reasoning. So let's summarize what we have here. Our knowledge began, our whole understanding began with the question, where did the solar system come from? And in the scientific approach, we then began with empiricism. We looked for observational data, and we saw things like the flatness of the solar system, the prograde motion of almost everything in the solar system, the composition of the solar system matching the composition of nebulae, the centrality of the sun, and the different types of planets. And then we used our minds. We used rationalism in the form of deductive reasoning to say what kind of story would logically result in all of these observations. And we came up with the nebular theory. To test nebular theory, we again relied on rationalism, on the power of our minds, again using deductive reasoning to ask ourselves what would be observable consequence that could be deduced from this theory. And so the flatness of the solar system, logically, that should mean there should be the rotation of the solar system, other nebulae should be rotating in space. Another logical consequent of nebular theory would be that there should be other flat nebulae. A third one would be that we should observe new stars, protostars, forming in other nebulae. A fourth logical prediction is that we should observe protoplanets in the protoplanetary disks of other nebulae. And a fifth one was that we should observe stars blowing away their nebulae, newborn stars. And so then, having now relied on rationalism, we now go back to empiricism. And we look for each of these predictions. So we looked for rotating nebulae and we found them. We looked for other flat nebulae and we found the proplids or protoplanetary disks. We looked for new stars in other nebulae and found the protostars. We looked for protoplanets in other nebulae and we found those clumping, those hot spots that represented clumping in the protoplanets. And we looked for stars blowing away their nebulae and found the evaporating gaseous globules. Again, each individual prediction, successful prediction, on its own is logically invalid, but when you put all these together inductively, the hypothesis made a correct prediction this time, it made a correct prediction here, it made a correct prediction here, and here, and here, and so we have reason to believe then that it will make correct predictions every time. And to make correct predictions every time, it has to actually be true. This whole process of combining deductive reasoning, empiricism, and inductive reasoning is what we call abductive reasoning. So why should you believe the nebular theory? Remember, the whole point of logical reasoning is to give us reasons for believing ideas. Why should you believe the nebular theory? Because having developed it using a scientific approach, using the scientific method, the nebular theory explains many of the features of the solar system using deductive reasoning that we'd already observed before we ever developed the theory. Things like the flatness of the solar system, that should be prograde motion, not retrograde motion, the composition of the solar system, and so on. But more impressively, it also successfully predicted many now empirically observed phenomena that were unknown before the hypothesis was developed. Things like nebular rotation, protoplanetary disks around other stars, protostars within other nebulae, protoplanets accreting within protoplanetary disks, and the evaporating gaseous globules. This is very impressive when you can predict this should exist, you should be able to observe it, and then you do go out and observe it. So this gives us strong reason for believing nebular hypothesis, enough reason that many astronomers are comfortable now calling it nebular theory. In essence, what's happened is we have tried at least 5 times to disprove the theory by denying the consequent. And the fact that we failed all 5 times to deny the consequent gives us a strong inductive argument for believing that this hypothesis is correct. So together, all of this makes a very strong abductive argument to say that, yes, this really is the way our solar system formed. However, there are a few problems remaining. One is that there are still features of the solar system we haven't explained. Things like the asteroid belt. Why did that material not accrete into a planet in that very large gap between Mars and Jupiter? The Oort cloud. Why is the Oort cloud spherical when the rest of the solar system is flat? And how did it get that far from the sun? And then this period when material started to fly all over the solar system about 1 billion years after its formation, what we call the late heavy bombardment. So there are still some details we need to work in, which means we perhaps need to refine our hypothesis. But the biggest challenge remaining is that all of this is based on only a single example of a solar system. We develop nebular theory only based on observations of our solar system, not any other solar systems. So are we perhaps engaging in the logical fallacy of the hasty conclusion? In order to know that, what do we need to do? We need to look for other solar systems and see whether they match up with what nebular theory predicts. And that will be for the next lesson.